Well, hi everyone. Today I'm going to talk about a model reference adaptive control for online policy adaptation and network synchronization. My name is Miguel Felipe Arevalo, and I'm working with the professors Cesar Uribe and Eduardo Mojica. Okay, a brief outline of the work that I'm going to present today. Basically, I have a quick motivation about the problem and the theoretical results of the strategy that we defined as a distributed model reference adaptive control with reinforcement learning. And finally, some conclusions and simulation results. Okay, basically, the context that we have for this kind of works is networked systems, because we know that nowadays we have a lot of application of systems that are connected and that have a specific task to accomplish the whole network. So, for example, I don't know, a network of cars or of a network of drones. In modeling case like social networks, we have a lot of application and we want to prove some control laws that synchronize a network of agents in a specific task that we want to accomplish. Okay, so for the problem formulation, basically we have a network of end agents that are represented as a continuous deterministic dynamic, commonly linear system, with the particular case that we have a partially unknown results that basically in this case is the matrix related with the states. And in this kind of problem, we work with a kind of linear follower approach. So we need to define the reference models that have the same behavior of a linear system, but with the particular case that we have the subscript m to talk about it. Okay, so basically in this particular case, we have a model, a reference model that is directly connected with an agent that in this case we defined as a leader. This leader agent is the only one that have a direct communication with the reference. And inside of it, we have a reinforcement learning algorithm that try to synchronize with the reference one. Yeah, but what happened that the behavior of all the agents have heterogeneous aspects, so we need to work with it. Yeah, so to work with it, we need to extend the theory with a model reference adaptive control technique that the idea is to improve the reinforcement learning algorithms that we have. So for this, we need to work with a communication graph that in this particular case needs to be unweighted, directed, and acyclic, and that needs to have a direct spanning tree that needs to be connected with the leader. So to work with it, we need to define an adaptive control law that basically takes the commonly form of a model reference adaptive control and in a centralized way have the form that you can see in the slide with the u sub 1. And this control law is composed by some adaptive gains that are related with the reference states and with the reference signal that the reference model have. Yeah, in this particular case, we extend this reference signal with an augmented reference signal chi. Well, in a centralized way, the adaptive law that we work is the constant that you can see with the case in the slide. Okay, and in a distributed way, we have an extension of the centralized control law that we have. This extension is basically composed of the links that an agent have with the other ones in its neighborhood. And in this particular case, we need to consider a synchronization error that basically is the difference between the states of some agents in comparison with another one. And here we have the constant related with the states and with the reference signal, and a new constant that is connected or related with the other agents states that have in its neighborhood. Yeah. So with this, we defined the simulation experiment that basically is composed of network of inverted pendulums that have a nonlinear behavior and a linearized behavior as well. We can see that if we change the parameters of these inverted pendulums, we have some problems, some failures in its performance when we are talking just of a reinforcement learning algorithm. And the final result is that if we are working with a nonlinear reference and we include the model reference adaptive control technique and a communication graph, we accomplish a synchronization even with the parameters of the network have some variation between them. Okay, so finally, as a conclusion, we propose a framework with a model reference adaptive control base and with a reinforcement learning algorithm. These model reference adaptive control techniques improve the common reinforcement learning algorithms and have a better performance in a distributed way. And a theoretical result, we define some stability analysis using Lyapunov theory to prove and to guarantee the convergence of the proposed laws that we have. Okay, so thank you so much and see you next time.